This is your mini lecture for lesson 110. So we're learning about graphing logarithmic functions. You might not have known this, but a logarithmic function, you have never even probably graphed them before, but they're actually the inverse of an exponential. I think we talked a little tiny bit about exponentials on one of these videos. Anyway, an exponential function has a shape like this, and then the logarithmic function, see how this is y equals 2 to the x? This is y equals log base 2 of x. So they're reflected across this line y equals x. And so one way to graph a logarithmic function is just to graph the inverse and then reflect it across this line y equals x. Since they're inverses of each other, the x's and y's are switched. You know, like if this has a point 0, 1, this top graph, then this bottom graph will have 1, 0. So you can kind of flip the ordered pairs on them if you want to. I sometimes do that to graph them more easily. And since you're allowed to do that, since that's how they work, the domain and range of the functions are switched too. And you might have noticed that in some of your tests that we've been giving you, they ask you about domains and ranges of inverses. And so it turns out whatever the domain of the original function is, it ends up being the range of the inverse, and that's because the x and y values are switched. So what else do you need to know? You need to know this is the form, oh, you can't see it. This is the form of a logarithmic function. So this number right out here will kind of stretch the graph, and then I think when the base is a larger number, it actually compresses the graph. Or let's read what it says. When graphing a logarithmic function, make note of the three constants. So there's a, it's a multiplier, b is the base, c is the coefficient of x. I think you're going to actually explore what these three constants do right here. So let's look right here. Okay, it tells you exactly what happens. So on page 765, it says, compare the graphs to see the effect of the variable a. So what's a doing to the graph? So like this black, hopefully you can see this. You can look in your own book if you can't see it. This graph has a 2 in front of it, and look, it's like higher, it's taller, it's got stretched a little bit. And this one doesn't. So the number out front, a, can give you a vertical stretch or compression. It affects the height of the graph. Okay, and then now on these two, on this top one, the base is e. If you guys remember, if it's an ln and there's nothing written there, the base is e. E is just a number that's about 2.71-ish. Okay, so this one's base is 2.71. This one is base 10. So this has a bigger base, yet it's shorter, or it's compressed more. Okay, so the bigger base actually makes the height shorter on the graph. I know it's kind of opposite of what you would think. And then let's look at these three graphs. The multiplier inside the argument, the bigger it is, the higher the graph, the more it stretches the graph. So we just want you to notice those effects. A lot of times you're just going to plot some points. So I'm just going to do letter A, and then if I have time, I'm also going to do letter C for you. Here's letter A, and I don't think I assigned the other ones because they like you to use a graphing calculator, and we're not going to do that. So they've asked me in letter A to make a table of these values. They gave me these values. I didn't just decide on those. They gave them to me in the problem. and then that's my function. And they say make a table using the given values to graph the function and its inverse. So I need to graph the function and its inverse and describe the domain and the range of the function. So, okay, so I'm going to plug in -2 right here. So what's 3 to the -2? Let's see, negative exponent, that makes it, flip upside down, so it'll be 1 over 3 squared, that would be 1/9. Remember negative exponent, like 3 to the -1, that's just 1/3. Anything to the 0 power is 1, anything to the 1 power is itself, and then 3 squared is 9. So I'll just use these values, just graph my function. Actually, I could have, I think the function's mostly going to be right here, and I didn't have to make a big part of my graph on the left. This can be y, and this can be x. Okay, so I need -2 and 1/9. -2, and then that's 1. So it's going to be way, way down there. And then -1 and 1/3, still way down there. And then 0 and 1. And then 1 and 3. And then 2 and 9. That's at the top of my graph. 2 and 9. Okay, so here's how my graph's going. Whoa, like that. If I want to see its inverse, well, they just now told us that its inverse is going to be what? F of x equals log base 3 of x. Those are inverses of each other. So I need to get the line y equals x here. And if I wanted to eyeball it, I could just eyeball it and say, well, it's gonna look like I folded this paper over, and this, came over here somehow, like that probably. But really, I can just use these ordered pairs. I can reverse them. That's what I like to do. I like to reverse them. So I can go 1/9 comma -2. So 1/9 comma -2. And then I can go, see how I'm using the y first and the x second, 1/3 comma -1. 1/3 comma -1, so it's kind of, and then 1, see I'm doing it backwards, 1 comma 0. And then 3 comma 1 comma 1. And then 2 comma 9. Oh, sorry, I did it backwards. 3 comma 1, that's what I wanted. 9 comma 2. 2, 3, 4, 5, 6, 7, 8, 9 comma 2. So you can see, and that's what, hopefully that's what you thought it would look like a mirror image. Okay, so this one is y, or I guess I'll call it f of x. F of x equals log base 3 of x. And this one's f of x equals 3 to the x. Okay, and is that, okay, so I have to hurry because I only have 1 minute left on my YouTube. The domain of the first function, if I look at it, it's all reals. This is of f of x. It's all reals, and the range is all the positive numbers. So y greater than 0 or something like that. So that would be for f of x. And then for f inverse, the domain would be the x is greater than 0, and the range would be the reals. See how they just flipped? Like the domain here is going to be the range here. And okay, that's all.